In this lesson, we are going to look at the commutative properties of numbers. Now, when you think commutative, you're thinking of commuting or moving from one place to the next, and you're going to start thinking, then that means numbers can move. Yes, numbers can move. So let's say, for example, that we are looking at the numbers 9 plus 27. We see that if we have 9 plus 27, it can also be written as 27 plus 9, and the result ends up at the same point for each case, which is 36. Now, say for instance, you are given this extremely long addition to do. What you can do is you can actually move the numbers around into something, for example, like ascending order. Or let's say, for example, you have the numbers 4 plus 5 plus 2 plus 5 plus 8 plus 6. You can actually move these numbers around to make the additions easier. And watch how you do it. You simply say, okay, I could put the 5 plus the 5 here together, and I could take the 8 and I put the 2 here after it, and then I take the 6 and I put the 4 here after it. And notice what I did. I can simply say 5 plus 5, 10, 8 plus 2 is 10, 6 plus 4 is 10, and 10 plus 10 plus 10 is equal to 30. And that's the use of the commutative property. And we are going to add in a few changes. We're going to put a minus here. We're going to put some minuses here as well. And then we're going to put in some new values. Let's say plus 7 plus 3. Now watch what we can do. We can take all the minuses and just group them together. We can take the positive is understood in front of the 4, so we can see the plus 4 comes right here, the plus 6, then we have the plus 7, then the plus 3, then we could put the minus 5, minus 2, minus 8, and then once we are able to do that, we can simply find the result of this, which is 20. And then we can simply find the result of this. Notice right away that these numbers comes up to a minus 20. And once we have those two results, we'll be seeing that we'd get a 0 right at the end of it. Notice what we did. We took the number with the sign in front of it and we moved it to a position that was convenient for us to work with. This property is very useful, and you can see where it would make your calculations a whole lot easier. Similarly, we can look at the commutative property for multiplication, and it does the same. We say 5 by 12 is the same as 12 by 5. And when we think of our rectangles, we can see that this is exactly the same. If I have a 12 here and I have a 5 here, the area of this rectangle, which is the 5 by the 12, is going to be the same as the area of this rectangle here, which can be 12 by the 5. And you can see right away, commutative property for multiplication holds.